This is Chapter 4, Problem 33. We have a plane diving with a constant speed at an angle of 53 degrees with the vertical, and it's going to release a projectile at an altitude of 730 meters. We know that the object is going to hit the ground 5 seconds after release. Now, I've drawn a picture of this scenario. Notice that the angle is 53 degrees with the vertical, so it's kind of opening that would be east of south. And then the object is going to fall 730 meters. Now, the key to this problem, very similar to the problem that we did earlier with the balloon and on one of my tests, if you'll remember, is that the object, when it's released, does not have a y-component velocity of 0. Instead, it's going to have the initial velocity that the plane is traveling. Notice that the plane is traveling at an angle, so that means that the initial velocity along the y direction is going to be v naught y, and that's equal to the velocity of the plane multiplied by the cosine of the angle 53 degrees. So that is the y-component velocity of the plane. Now we need to set up the displacement formula for the object as it falls. The object is going to fall 730 meters, and that's going to be equal to the initial velocity along the y direction, v, times the cosine of 53, multiplied by the time, which we know to be 5 seconds. That's the time that it takes to impact. And then we're going to add to that the acceleration component from gravity, 9.8 meters per second squared times the time squared. Now, somebody's probably pointing out right now that Mr. Steinman's being pretty weak in his notation, that the object is falling, so it should be negative, and that the acceleration should also be negative because it's negative 9.8 meters per second squared when an object is in free fall. Well, I've kind of accounted for that already. The 730 meters is straight down, so that's negative. The velocity along the y direction is down as well because the plane is diving, so that's negative. And then the acceleration of gravity is negative as well. So that means we have three negative quantities. Every quantity in the equation has a negative, so the negatives can drop out and we just have the positives. So 730 is equal to the velocity of the plane times the cosine of 53. That comes from the y-component velocity of the plane. We multiply by the time of 5 seconds to impact, and then we add to that 1/2 the acceleration of gravity, 9.8 meters per second squared, times the time squared, which is 5 seconds. Solving for v, the velocity of the plane, we get that the velocity of the plane is equal to about 201.89 meters per second. So that's the velocity of the plane. Now, in the next part, in part B of the problem, it says how far does the projectile travel horizontally during the flight? Well, in this case, we are going to use the x component of the plane's velocity. I'll draw, once again, the velocity of the plane and set up its x and y components. The velocity of the plane we found to be 201.89, and we know the angle is 53 degrees. So we can solve for the x component of the velocity, v naught x, and that's equal to the velocity of the plane, 201.89, multiplied by the sine this time of 53 degrees. Notice that it's the sine of the angle, and we get a v naught x equal to 161.25 meters per second. As is the case with these free fall problems, as long as they don't tell you anything about an acceleration in the x direction, you assume that that velocity along x is constant. So now we set up our delta x formula, the displacement along x. That would be equal to the 161.25 multiplied by the 5 seconds that it's in the air. And now we have a delta x equal to 806.18 meters. So that is the horizontal distance that the projectile travels while it is in flight for 5 seconds. For the last part, we need to find the vertical component of the box's velocity just before it hits the ground. In this case, we're going to use the Vy is equal to V naught y plus the acceleration on y times the time. We know the initial velocity along the y direction. That's going to be equal to 201.89 multiplied by the cosine of 53. And then we add to that the acceleration of gravity, 9.8, multiplied by the 5 seconds that the object is in the air. Once again, somebody's probably going to point out that these should all be negatives. Well, Vy should be negative, V naught y is negative, and the acceleration is negative. So once again, we have all positive numbers because the minus sign drops out. We solve for the vertical component of the box just before it hits the ground, and we get 170.5 meters per second. And just to be clear, this is going down. Last time I looked, you don't throw an object up in the air and watch it just keep on rocketing upward. So the velocity is down. And that's it for this problem.